This is video 2 in section 5A, which is Fundamentals of Statistics. We're going to begin this section for video 2 with a recap of what was covered in video 1. The first thing we covered in video 1 was the definition of statistics, which is what we're going to be studying in chapter 5 and chapter 6. So statistics is defined as the science of collecting, organizing, and interpreting data, and it also had the other definition of the data itself. In video 1, we also discussed the difference between population parameters and sample statistics. Recall that you take a sample from the population and you use the calculations from that sample, which are called the statistics, which might be mean, median, mode, standard deviation, which, just to clarify, those will be discussed in chapter 6. And they are used to estimate what the population parameter is going to do. In video 1, we also talked about 4 basic sampling methods, the first one being a simple random sample, the second being systematic sampling, the third being convenient sampling, and the fourth being stratified sampling. Also in video 1, we talked about the basic steps in conducting a statistical study. First was the goal, choose your sample, collect your data, use sample statistics that you calculate to approximate population parameters, and then have a conclusion. This is the recap of video 1. Now we're going to move on to some new material that we will be covering in this video. So in this video, we will be talking about 2 types of statistical studies. The first type is called an observational study, and the second type is called an experiment. These studies are used whether you are analyzing an existing study or setting up a new study on your own. In an observational study, researchers observe or measure characteristic of sample members but do not modify or attempt to influence these characteristics. A good example of an observational study is one that we looked at previously in video 1. If you wanted to study the weights of your college students' backpacks, you would not be doing anything to modify those weights or influence the characteristic of those weights. In an experiment, researchers apply a treatment to some or all of the sample members and then look to see whether the treatment has any effect. A good example of an experiment that was actually conducted was the effect of Botox treatments on migraine headaches. Of course, the treatment is the Botox, and they're trying to determine whether that treatment has any effect on reducing the intensity or completely eliminating the migraine headache. For the next few minutes, we're going to concentrate on the second type of statistical study, which is the experiment. Within an experiment, you have 2 types of groups. The first type of group is your treatment group. And your treatment group, of course, is the group of the sample members who receive the treatment, which in the example of the Botox effect on migraine headaches, that particular group would be receiving the Botox treatment. Also in an experiment, it's very good to also have what we call the control group. And the control group is the group of the sample members who do not receive the treatment. So, of course, in the example that we were looking at, they are not going to receive the Botox treatment. So what you would do when you're setting up your experiment is you would determine the goal of your study. Then you would select your sample using one of the sampling methods that we previously talked about. And then the next step would be, within that sampling, is you would assign the sample members to each of the groups above randomly. Also in an experiment, we have something called the placebo. And a placebo is identical in appearance to the treatment, but lacks the active ingredient in the treatment. So the control group that we talked about above would receive the placebo. The placebo effect would occur when patients improve simply because they believe they are receiving a useful treatment, but they actually did receive the placebo. So they're in the control group, but they actually think they got better even though they didn't receive the active ingredient. Okay, in our Botox example, on the effect of Botox on migraine headaches, your treatment group, of course, would receive the Botox. And then your control group would receive a placebo, which resembles the Botox, but is really like, quote unquote, a sugar pill or a sugar Botox, so to speak, for that particular example. Also, in an experiment, there's something that can be used called blinding. And there are two types of blinding. A single blind experiment is basically what it says it is. An experiment is single blind if the participants do not know if they are in the treatment group or the control group, but the experimenters do know. In a double blind experiment, which is the other type, neither the participants nor the experimenters know who is in the control group and who is in the treatment group. A double blind is used when the experimenters might bias results if they knew, such as if the experimenter conducting the study was also the person who manufactured the ingredient that they are trying to determine if it has an effect. So for example, in our Botox effect on migraine headaches, I know that it was at least a single blind experiment, but it would have to be a double blind experiment if, per se, the person conducting the study are the manufacturers of Botox, because of course they're biased and they want the Botox treatment to have a good effect on that. So the last few slides talked about the experiment. We're going to go back to the observational study, and we're going to talk about a specific type of observational study, which is called a case control study. A case control study is like an experiment, but groups are not randomly assigned. The main reason that this is done, a case control study versus an experiment, is that to assign the groups randomly would be unethical. And we will talk about an example of that in a minute after we discuss the case control study itself. So in your case control study, you're going to have two separate groups. The first type of group is called your cases, and that's the same as the treatment group in an experiment. So that's your cases. The second group is called your controls, and that group is identical to the control group in your experiment. So again, your cases do receive the treatment, and the controls do not receive the treatment being studied. So a good example of where we would use a case control study instead of an experiment would be if we wanted to study the effect of cocaine use by mothers on the baby's development. Okay, we said that case control studies are used a lot of times because it would be unethical to assign the groups randomly. So who's going to decide who's going to get the cocaine and who's going to not receive the cocaine? So what we would do, the cases would be, of course, mothers that had used cocaine during pregnancy, and the control group would be mothers that did not use cocaine. It would be unethical for us to randomly assign people to the cases group and tell those mothers that, oh, you need to have cocaine in your system while you're pregnant, and we're just going to see what that does to your baby's development. So in this particular case, a case control study applies instead of an experiment, obviously. So to conclude section 5A, we're going to look at surveys and opinion polls. So in surveys and opinion polls, just like the studies we just discussed, we're using a sample to estimate what the population is doing. So the first term we want to talk about is margin of error. And margin of error in a statistical study is used to describe a confidence interval that is likely to contain the true population parameter. So we find the confidence interval by adding and subtracting the margin of error from the sample statistic obtained in the study. Just remember that all through this, we're using the sample to estimate the population. So the margin of error is something that we could calculate statistically, but in this particular class, we're not going to calculate it, but we're going to use it in order to calculate a confidence interval. So to calculate your confidence interval, you're going to take the sample statistic that you calculated from your sample, such as the mean, and add and subtract the margin of error to that sample statistic to get your range of values that is in that confidence interval. So we would say we're 95% confident that the true population parameter lies between the first value, the sample statistic minus the margin of error, and the sample statistic plus the margin of error. A good application of margin of error and confidence intervals is the election polls. So let's say we have another Clinton versus Bush election, and let's say that when we did our sample and we collected our data and determined how many people were going to vote for Clinton and how many were going to vote for Bush in the election, from that sample we got 40% for Clinton and 51% for Bush. So let's just say that the margin of error is 4%. So we can calculate our confidence interval by adding and subtracting that 4% from the 40% for Clinton and the 51% for Bush. So in the end, our confidence intervals at the bottom here are Clinton got between 36 and 44% of the American citizens' vote, and Bush got between 47% and 56%. Because there's no overlap between these confidence intervals, we can say that Bush will be the winner of this particular election. Okay, so let's continue with the same example. Clinton got 40%, Bush got 51% from our sample, but if you notice, I changed the margin of error now from 4% to 7%. So when I calculate my confidence intervals by adding and subtracting that 7% from the 40% for Clinton and the 51% for Bush, I get the following confidence intervals. Clinton's confidence interval is 33% to 47%, and Bush's confidence interval is 44% to 58%. Because there is an overlap in these confidence intervals, what we would say is that this election is too close to call. So finally, we want to interpret what the confidence interval means. So what you say then is that I am 95% confident that Clinton will receive between 36% and 44% of the vote. And the 40%, recall, was our sample statistic, and our margin of error was 4%. Just keep in mind that when the election polls are announced, they should give you a margin of error, and now you should know what that means so you can kind of figure out if the election is too close to call or if there is an obvious winner based on that sample and the margin of error that is given. That concludes this section, which is 5A in the Math 111 course.